Hi there, this is Eva Kiss from Ontoprise with a short tutorial on platform management with OWL in Object Logic. This implementation is one of the results of work package tree execution and inference, and this proof of concept is part of deliverable 6.2 final showcase. The systems enables administrators to answer questions like which systems or components have as input or output a given data type, or which components are used by a given persona, for example Alice the domain expert. The architecture of the system relies on the Ontoprise product suite on OntoBroker and OntoStudio, and the ontologies have been modeled in Object Logic as well as the OWL rules. Note that we use only OWL reasoning and no other additional user-defined rules. The three ontologies on which the system relies are the applications ontology, the user ontology, and the platform ontology. The application ontology models the hierarchy of data objects, systems and components and the relations between them. Note that we distinguish between abstract components and concrete components. For example, a concrete component like OntoBroker has as input different data types, as output other data types, implements an abstract component like rule execution, and is used by certain personas. The user ontology models the domain of organizations, persons, and personas. Personas are a user profile of typical users using a given IT component. Within OntoRule, 5 types of personas have been identified by our usability experts. One of them is, for example, Alice, the domain expert. The third ontology, the platform ontology, contains the queries which an administrator would like to have answered, and also the complex class constructs and other additional features offered by OWL. The rules from the OWL axiom set have been implemented as object logic rules into a separate ontology. So we see, for example, the rules for some values from have been implemented using a reserved internal predicate some values from. Some of the rules from the OWL axiom set have been implemented as constraints. We have a specific handling for equality, disjoint classes, keys, for maximum cardinality constraints, and also for functional and inverse functional properties. We use the OntoStudio constraint validator mechanism to find those individuals which violate given constraints. So in our case, we have defined a constraint for the person class consisting of name and birth date, and this validation will return as result those persons which are different but have identical keys, so have same names and birth dates. So, which queries do we typically want to answer? The simplest is which concrete components have as input OWL. Expected answer set is OntoStudio, XPR OWL, OntoBroker, and Parrot. This is our first query. Here we go. We run the query and see that XPR OWL, Parrot, OntoStudio, and OntoBroker are returned. Now, to go further, we want to see which concrete components have as output owl. The expected result set is terminae, ontostudio, and ontobroker. This is our second query, and here we already rely on a owl RL construct, namely on the property chain construct. We define a new property app has output with name by chaining two other properties, app has output and app name. And this way we have a shortcut notation which comes in handy if we would have more properties to chain. In this case, we get the expected result set. We see here we have terminae, ontostudio, and ontobroker like expected. Next query, which concrete components are used by Alice, the domain expert? Here we note that we simply ask for the individuals in a class components used by domain experts. We also see that this class has been defined as an OWL-RL complex class construct. We use intersection of and some values from. And due to the OWL-RL rule set, without any additional user-defined rules, we get the right answer set. We check, yes, Paris 3 rule editor, JRules consistency maintenance plugin, and ontostudio are returned. Now, our fourth and last query wants to illustrate the use of the OWL-CMS construct. Parrot is an application documentation service which generates HTML documentations from OWL and RIF. Now we want to know all of the resource locations of Parrot because Parrot in the internet is present on different sites, on the ONTORULE site, on the ONTORULE internal wiki, as well as on the SourceForge. And by declaring all these resources, all these individuals as same, with our OWL-RL in object logic syntax, we obtain with a simple query, we obtain all this information, and we can see that indeed we obtain the locations for Parrot from the ONTORULE website, from the internal wiki, and from SourceForge. So we consider this to be a very important feature offered by OWL and the OWL-RL reasoning. So this is about what OWL-RL in object logic offers as features, and in applications like this we have found it to be very useful and sufficient. Thank you very much for your attention, and goodbye.